It was a holy moment when the Andromeda Nebula overnight became the Andromeda Galaxy. The James Webb Telescope has identified 6 galaxies that exist 500 million years after the Big Bang. This is incredible. When you look at the night sky, a pinpoint of light, when expanded, gives you one of these pictures from the Webb Space Telescope. It was a holy moment as the Andromeda Nebula transformed into the Andromeda Galaxy. For years, our understanding of the Andromeda Galaxy was limited to basic observations. However, with advancements in technology and the birth of the James Webb Space Telescope, our understanding has grown beyond measure. Now, things are about to change as the James Webb Space Telescope has detected alarming signals coming from the Andromeda Galaxy. These signals have sent shockwaves through the scientific community, leaving astronomers both inspired and curious. But what exactly do these signals mean, and why are they causing such a stir among astronomers? Join us as, just 2 minutes ago, the James Webb Telescope shut down after receiving alarming signals from the Andromeda Galaxy. Before, we could see far beyond our eyes into the cosmos. Astronomers believed the Milky Way to be the whole universe. This lack of insight was primarily due to limited technology for seeing various galaxies and individual stars. However, everything changed when we discovered the Andromeda Galaxy. It served as our first hint that the universe stretches far beyond the Milky Way. In the 17th century, Galileo Galilei's pioneering work with telescopes revealed the Milky Way's true nature. He saw that the Milky Way had numerous stars, challenging the prevailing idea of its singular importance. Everything changed in the 1920s when Edwin Hubble discovered distant objects beyond the Milky Way using the Hooker telescope. Edwin noticed that these celestial objects moving through the cosmos were galaxies different from the Milky Way. One of the galaxies was the Andromeda Galaxy, or M31. While this was the first time we saw the Andromeda Galaxy through a telescope, Persian astronomer Abd al-Rahman al-Sufi first noted it around the 10th century. Thanks to technological advancements in the 20th century, astronomers could see and understand the true nature and essence of Andromeda. Andromeda is a nebulous cloud consisting of a vast galaxy of stars, similar to our Milky Way. Our cosmic neighbor is approximately 2.5 million light-years away from the Milky Way. Since its discovery, the way we study Andromeda has profoundly evolved. We have moved from ground-based observations through telescopes to space observatories like the Hubble and the James Webb Space Telescope. Each advancement in technology has taken us to new heights, helping us understand the secrets of the Andromeda Galaxy. We now have more information and insight into its composition and structure, making Andromeda a benchmark for studying the formation and growth of galaxies. This has shed more light on the broader working principles of the universe. Scientists believe that to have a better understanding of our universe and the Milky Way, we must study the relationship between Andromeda and the Milky Way. This is especially true given that both galaxies are bound to collide in approximately 4 billion years. While studies and investigations have progressed, the James Webb Telescope recently received a concerning signal from Andromeda. This alarming signal baffles scientists worldwide, prompting questions about its exact origin and potential implications. The James Webb Telescope's advanced sensors have detected unusual activity right inside Andromeda's core. The signal sent back to scientists shows results that differ significantly from past observations, intriguing scientists worldwide. The signal indicates major processes going on within the galaxy, potentially linked to its supermassive black hole or previously undiscovered occurrences. Notably, one of the latest findings indicates that Andromeda's mass may be much bigger than that of the Milky Way, reshaping our understanding of both galaxy sizes. The James Webb Telescope has also provided detailed images and spectra of Andromeda, unveiling the formation of new stars and their chemical compositions. This new data is important for understanding galactic evolution and potential conditions for life. Additionally, the data from the telescope suggests increased activity in Andromeda's active galactic nucleus. This has ultimately impacted its surrounding environment and is predicted to shape its future structure. Furthermore, by looking into the gravitational effects on stars within Andromeda, researchers gain insights into the distribution of mysterious dark matter throughout the galaxy. Hopefully, this helps further our understanding of its influence on the dynamics at play in the cosmos. Understanding dark matter and its impact on the universe is one of astronomy's greatest puzzles. Recent breakthroughs by the James Webb Telescope have motivated various studies worldwide as scientists look into the secrets of Andromeda. With more information coming to light, we now know more about the galaxy's past and future. So, what have we learned about the Andromeda Galaxy through various studies? Andromeda has shown impressive characteristics that distinguish it from other galaxies spread across the universe. Its sheer size commands attention, with recent assessments suggesting a diameter spanning around 220,000 light-years. This figure makes it one of the largest galaxies in the local group, even bigger than the Milky Way. This vast scale contributes to its mass, consisting of an estimated trillion stars, surpassing our galaxy in stellar count. Research also finds the galaxy's structure fascinating. Unlike a typical spiral galaxy, Andromeda has a bulging center and a dense nucleus enclosed within rings of dust and gas. This is undoubtedly a fertile ground for ongoing star formation. Such features show a dynamic galaxy created by continual processes shaping its evolution. Among its many features, one of particular interest is its nucleus. It is characterized by a double peak emission, hinting at the presence of a supermassive black hole, similar to but different from the Milky Ways. This offers important insights into the nature and activities of these massive, matter-eating holes. The Andromeda Galaxy is also encircled by a sphere of stellar debris, consisting of stars, planetary, and globular clusters, spanning hundreds of thousands of light-years in diameter. This cosmic covering tells a captivating, detailed story of the galaxy's unique origin and history. The 460 globular clusters found in Andromeda also offer insight into the formation of stars in the very early stages. This provides a clear explanation of the formation of star clusters and the early development of the galaxy. In piecing together the mysteries of Andromeda, astronomers are one step closer to understanding the cosmic relevance of dark matter. However, one question lingers. How do they account for its mysterious nature and the role it plays in the dynamics of galaxies? Andromeda boasts another distinctive feature: its satellite galaxies. Its halo structure is made up of more than 20 smaller galaxies, and some of them are undergoing tidal stripping of their stars and gas. This process involves a larger galaxy pulling in and destroying neighboring small galaxies. This displays the active nature of cosmic evolution and portrays how galaxies grow and interact with each other over time. So, what does the future hold for the Andromeda Galaxy? The shape and direction of its movement fascinate not only astronomers but also those seeking to understand the cosmos. The possibility of its transition from a spiral to a ring galaxy is centrally strategic in Andromeda's development. Evidence points to a process that could lead to other rare combinations, possibly from galactic collisions or close interactions with other galaxies. If Andromeda really is moving in this direction, it means that it has experienced many interactions with other galaxies since its birth. Ultimately, Andromeda's future depends on the imminent collision with the Milky Way. According to these models, the collision is estimated to occur roughly 4 billion years from now. The result of such a collision is the birth of a new galaxy from these two giant celestial entities. Though destructive, the collision is a natural part of galactic development. However, due to the vast distances between the galaxies, this galactic collision isn't a direct impact. After the collision, both galaxies would be radically restructured, forming new shapes and compositions. The interaction of their gases and dust will stir up new rounds of star creation, leading to a large spectacle in the sky as the merging objects twinkle brightly. Finally, such a cosmic event will result in the formation of a single elliptical galaxy. This type of collision isn't unique, as the universe has a long history of such events. However, our direct participation makes it an event of interest to us. Additionally, the predicted collision of the supermassive black holes at the nucleus of the two galaxies adds more mystery to the celestial show. This suggests a complex and deep nature of cosmic evolution. The merger is predicted to produce explosions from matter being engulfed by the black hole, which will release extensive radiation. This process offers important data about how galaxies move throughout their lifespan and how black holes affect this evolution. However, it raises a crucial question. What will happen to our solar system after this merger is formed? Far from a total destruction of the solar system's orientation and conditions could be altered significantly. This implies possible orbit shifts or even ejection from the newly emerged galaxy. To understand this mechanism, scientists can study the magnitude of similar events happening and contextualize the eventual fate of our own galaxy. It is crucial to understand that a collision between stars is a rare event in space because of the vast intergalactic distances. However, the gravitational change could disturb stars' stable orbits, causing some stars, including our Sun, to change trajectory. Such a change could drastically disrupt the climate on Earth. One of the most critical changes humans could experience is moving further away from or closer to the Sun. This could lead to either warming or cooling effects. A warmer climate could make ice caps melt and sea levels rise, while a colder one would lead to a new form of ice age. On top of that, the geometry of such a setup might expose Earth to more cosmic radiation, impacting life forms. Meanwhile, as for the possible ejection of the solar system from the new galaxy, this isn't just a simple displacement. The solar system would continue its course in intergalactic space, separated from the galaxy. This scenario implies a more solitary future for the Earth, with fewer stars visible at night and less gravitational pull from neighboring celestial bodies. Yet, it also raises questions about the long-term sustainability of life in such an isolated environment. This transformation will likely reshape the dynamics of the universe, and astronomers must continue studying the signs of galactic collision in preparation for the future. The information provided by the James Webb Telescope is important to understanding the eventual fate of Andromeda and the Milky Way. Through advanced studies, we gain essential knowledge about the future. The science community is more than willing to closely observe the eventualities to understand how this cosmic merger will impact us all. Understanding Andromeda's secrets isn't just about examining a galaxy far away. It is about understanding the fate of our own Milky Way. By studying this process, we learn more about the universe's cosmic playbook, helping us better understand our past, present, and future.